What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to practice polynomial long division, which looks just like this. So here's a little preview. And we're going to go through these four examples where the first two have no remainder and the last two do have a remainder. So if you've already kind of practiced this and you're just trying to get more practice, pause the video, pencil and paper, try some of these. The video will be all time stamped up so you can skip around to what you need. Let's jump right into the first example. And since this is the first one, I want to talk a little bit about what exactly it is we're doing, how this makes sense mathematically, and then I won't bring it up again. The next examples we'll just go through, we'll find the answer. All right, so for this, what are we doing? We're dividing two polynomials. And what does this actually mean? Well, let's think about, we did this with whole numbers. Way back probably in like elementary school, we did stuff like this, 1053 divided by 9. And there are many different ways we can think about what this means, but my favorite, and I think aligns most closely with how we should think about polynomial division, is what do I multiply 9 by to get 1053? And that's exactly how we can think about this polynomial division problem. Here we have what we call a divisor. This is a divisor, and we're thinking about what do I multiply the divisor by, x plus 2. So x plus 2 times what? Let's put in parentheses here, question mark. X plus 2 times what equals this thing, which we can call the dividend. So I'll just write that out, dividend. Right, this is called the dividend. So x plus 2 times what equals this dividend, and that times what is our quotient. That's like the answer to the division problem, right? Just like this question mark here is our quotient. So that's what we're trying to figure out. What do we multiply x plus 2 by to get this dividend? And we can actually use a similar strategy that we could use for this whole number example. So when I saw this, I would think about, well, I know 9 times 100 is 900, and that's less than 1053. So let's write that out here. 9 times 100 is 900. So I can multiply 9 by a number that's at least 100, because that gives me 900, which is still less. And to figure out what else I need to multiply, I can subtract. And now I get what? 153. And now maybe I can say, well, there's at least another 10 nines in 153, because 10 times 9 is 90. So we can use this process of like multiplying, subtracting over and over till we have nothing left or there's a remainder. That's exactly what we do with polynomial division. Multiply, subtract until there's either nothing left or there's a remainder, and we'll learn how to deal with that in the third or fourth example. So hopefully this makes some sense. Let's go ahead and set up the actual division. So we always put the divisor out here to the left. We put the dividend under, sometimes this is called the house, under the house, right? And then here's where the quotient goes. That's where we're going to hopefully answer the question, what do I multiply x plus 2 by to get this dividend, x cubed plus 3x squared plus x minus 2? So how I can start answering this question, and this is how we should always start with polynomial long division. We should look at the first term, right? The biggest term of the divisor, and think about what can I multiply that by to get the biggest term of the dividend. So in this case, what do I multiply x by to get x cubed? And that's just x squared. I can multiply x by x squared to get x cubed. So I'm going to place the x squared actually here because just a personal thing, I like to align the columns, all the x squared, all the x's, that kind of thing. And now that this first term, so what we've just determined is that the first term of the quotient is x squared. That's the biggest term, right? The biggest power of x. And if that's the case, then that means that when I multiply out, I get x cubed plus 2x squared. So we're applying the distributive property. We're thinking about if this is the biggest powered term, then when I multiply these two things together, I'm going to get x cubed plus 2x squared. That's how our like FOIL works, right? Our distributive property. And so now I have both of these accounted for. I'm going to subtract. So this is exactly what we did when we subtracted the 900 with our whole number example. We're subtracting this. So just to review, what do I multiply x by to get x cubed? I put that there. That's x squared. I multiplied x squared by this entire binomial, right? X plus 2 to get x cubed plus 2x squared. And now I'm subtracting because I know that's already accounted for. The fact that this has to be x squared means that this has to exist. So now we're going to subtract and see what's left. Basic idea of what we've done so far. So here we got 0 x cubed minus x cubed. And again, we're subtracting this entire thing. I want to make this clear. Some teachers describe this as just change all the signs. They're like, oh, make that a minus, make that a minus. And that is true, but mathematically what's happening, the reason why that works is because mathematically we are subtracting. So I just want to make sure we all know that. We could write a minus here and a minus here. That's because that's what happens when you subtract an entire expression. That minus sign distributes. So here we end up with 0, and here we end up with plus x squared because we have 3x squared minus 2x squared. That leaves just 1 left. Now we repeat the process, right? What do I multiply x by to get x squared? And that's just x. And some teachers teach to anticipate, like we're going to end up subtracting, so we're going to bring down this plus x, and that's the next step, and that's totally fine. We could do that, or we could do it after we do this next part. Either way, as long as we make sure we don't forget about that. All right, so I already said, what do I multiply x by to get x squared? That's just x. So we've said this second term has to be x. That means when we do end up multiplying these out, we get x squared, that's x times x, plus 2x, right? So this is accounted for, so we want to take that away and think about what's left. Awesome. All right, x squared minus x squared is 0. X minus 2x is negative x. And now we can anticipate, we can bring down this negative 2 because we know we're going to end up multiplying some constant, have two things here, and end up subtracting. All right, so now what do we think about? What do I multiply x by to get negative x? That's just negative 1. Let's write it here, negative 1. And now when we actually do multiply, we get minus x, minus 2. These completely line up. When I subtract them, I am going to get 0. But we can actually write that out and see it, right? This becomes a plus, so we have negative x plus x, that's 0. And then we have negative 2 plus 2, that's also 0. And that's what should happen when there is no remainder, right? That's when we get 0 at the end. Everything cancels out. So what does that mean? Is that if I multiply x plus 2 by x squared plus x minus 1, I get exactly x cubed plus 3x squared plus x minus 2. So this is our quotient. This is the answer to this division question. And if you want to check your work, you can actually multiply these. Multiply out x squared plus x minus 1 times x plus 2. You'll get exactly this. Pretty cool. So we just answered the question. What do I multiply x plus 2 by to get this dividend? Awesome. All right, hopefully that made sense. Next example, we can go a little bit faster. Let me go ahead and set it up first. So I always write the divisor out here. The dividend goes under the house. And then remember, I'm trying to answer the question, what do I multiply 3x minus 2 by to get this polynomial under here? That's the quotient. That's what goes up here, the answer to our division problem. How do we always start? I'm looking at the biggest term of the divisor, and I'm thinking about what do I multiply this by to get the biggest term of the dividend. So what do I multiply 3x by to get 6x cubed? Well, I need to multiply 3 by 2 to get 6, and I need to multiply x by x squared to get x cubed. So we're going to write 2x squared. And now this next step actually always allows us to check our answer because we multiply this out. Well, if this is the first term of our quotient, then that means to multiply these together and get this, I'm going to end up multiplying 2x squared by 3x, and that's going to give me 6x cubed. And then I end up multiplying 2x squared by negative 2, which is going to give me negative 4x squared. And now I'm subtracting both of these, boom, right? Or changing signs. So now I get 0 here, and I get 29x squared minus a negative, right? So minus a negative is plus. I could do that. Like, oh, let's change them both to plus. Totally fine. I get 33x squared. Combining like terms here. Let me make this a little bit cleaner. 33x squared. I can anticipate. I know I'm going to end up subtracting stuff. I'm going to go ahead and bring this down. That's totally fine. Just remember, we only care about this biggest term. What do I multiply 3x by to get 33x squared? Let's see. 3 times what is 33? 10, 11. 3 times 11 is 33, and x times x is x squared. So plus 11x. Let's write that here. And now here's our chance to actually check our answer. 11x times 3x, that better give us 33x squared, which it does. 33x squared. And now I go, well, what's 11x times negative 2? That's minus 22x. And now I'm subtracting. I'm subtracting all of this. So I can change the signs. This becomes 0. Minus becomes plus, right? Because we're subtracting a negative. So 40x plus 22x is negative, let's see, negative 40x plus 22x is negative 18x, right? I have minus 40 and I'm adding 22, negative 18. Awesome. And now we can do our last sort of anticipation here. I'm bringing this 12 down. And this should be my last step. Remember, I'm looking at only this biggest thing here, negative 18x. What do I multiply 3x by to get negative 18x? That's just negative 6. And that's why it's so important to think about the sign of this, right? This negative being here. Make sure we're paying attention to that, because if we just write 6, we're wrong. So negative 6. Now we multiply negative 6 out, we get minus 18x. And then negative times a negative is a positive, plus 12. These exactly line up. That's what happens, right? That means there's no remainder, because when we actually subtract these, we get 0 and 0. There's nothing left, which means what do I multiply 3x minus 2 by to get 6x cubed plus 29x squared minus 40x plus 12? That's exactly this, 2x squared plus 11x minus 6. You could try it on your own if you want. So this is the answer to our division problem. This is the quotient. And let's move on to the next example. All right, so we've got our divisor on the outside. We've got our dividend under the house. We're trying to figure out what do I multiply 2x plus 1 by to get this dividend. We're going to start the same way we always start. What do I multiply 2x by, right, the biggest term in the divisor, to get the biggest term in the dividend, 4x cubed. So in this case, what do I multiply 2x by to get 4x cubed? Well, I need to multiply the 2 by 2 to get 4, and the x by x squared to get x cubed. So 2x squared. I'm going to write it here, 2x squared, and now I'm going to multiply. 2x times 2x squared is 4x cubed. We just said that was the case. And then 2x squared times 1, which is pretty easy. It's just itself, plus 2x squared. And now we can subtract. Subtracting this entire thing. You don't have to write the parentheses. If you want to change the signs, you can do that as well, as long as you know why that works. Here we have 0, those cancel, and now we have 10x squared minus 2x squared, which is just 8x squared, so positive 8x squared. Now we can anticipate subtracting. We can bring this down now if we want, but remember, we're just looking at this biggest exponent term, 8x squared. What do I multiply 2x by to get 8x squared? That is 4x, so we're going to write plus 4x here. And now we're going to multiply 4x times 2x gives us 8x squared. We already knew that. And then 4x times 1 is just 4x. So let's write this out and let's subtract. Boom, we're subtracting. So now we get 0 here, and we get 6x minus 4x, which is just a positive 2x that we are left with. Now we're on to our final step. What do I multiply 2x by to get 2x? That is plus 1. Okay, we can again anticipate. We can bring down as 3. We have to do it eventually. 1 times 2x is 2x. 1 times 1 is 1. And now look, these don't exactly line up. This is what's going to happen when there is a remainder. This means there's going to be a remainder. So 2x minus 2x gives me 0, but 3 minus 1 gives me 2, right? So I am left with 2. What can I multiply 2x by to get 2? Well, nothing. I can't get rid of that x, right? And so that 2 is chilling. That's the remainder. And here's how we're going to write it. We're going to say this is the quotient plus the remainder divided by the divisor, 2x plus 1. Okay, so this divided by this equals this entire thing here. Quotient plus remainder over divisor. Let's see if we can make a little bit of sense of why this is the case. So if we had 16 divided by 5, we could think about this as what do I multiply 5 by to get 16? So for this example, what can I multiply 5 by to get 16? Well, that's 3. That's the closest whole number, but we have 1 left over. That's our remainder, right? So how do we write what 16 divided by 5 is equal to? Well, it's equal to 3. And since there's 1 left over, that still needs to be divided by 5. Okay, so these are two different forms where I can get from here to here by multiplying both sides by 5, and I can get from here to here by dividing both sides by 5. So that's this sort of relationship between this multiplication form and this division form, and the same thing happened here with our example we looked at, this one. What we showed through our work is that 2x squared plus 4x plus 1 times 2x plus 1 is almost equal to the dividend, 4x cubed plus 10x squared plus 6x plus 3. We are left with 2, right? We have this 2 left over. They're almost equal. And so what do we do with that 2? Well, we add the 2 over the divisor, right? Which is exactly what we did here. This is the divisor. We added the remainder over the divisor, and we can kind of clearly see these two different forms. So this is what we showed through our algorithm, which is what do I multiply 2x plus 1 by to get this? And I said, well, I can multiply by this, but then I have to add 2. That's the remainder, right? So I can't exactly get this. I have to then add 2. So again, we could think about it that similar way where we could either think of the remainder over the divisor, or we could think of this entire thing being divided by the divisor, dividing both sides, because we want to write what the quotient is equal to. What is 4x cubed plus 10x squared plus 6x plus 3 divided by 2x plus 1? And to get there, we need to divide both sides by 2x plus 1, or we could just think of it again as this form, remainder over divisor. All right, hopefully I didn't go off on too much of a tangent. Let's jump into our last example here. Let me go ahead and set it up. All right, so I placed my divisor out here. I put the dividend under the house, and I included this example for a key reason, which is that it's missing a term. It has no x term. Here's what we always want to do when that happens. We want to use a placeholder. If there's no x term, we can write it as plus 0x. We want to use a placeholder for organizational purposes. You're going to see why once we jump into the example. So we start the same way we always start. What do I multiply x by to get x cubed? And that's just x squared. So let's write it here above in the x squared column. And x squared times x is in fact x cubed, and x squared times 3 is 3x squared. So plus 3x squared, subtract, subtract. Awesome. So we can change the signs. That's minus x cubed, 0. That's 4x squared minus 3x squared, which just leaves us with x squared. We can anticipate, we can bring down this plus 0x, and this is why we like to do this, because now I'm going to think about what do I multiply x by to get x squared, and that's just x. And now x times x is x squared. Quick maths, we already knew that. And then x times 3 is 3x. Here's why we like to have this placeholder, is because we need to account for this negative 3x. So it's going to be like 0 minus negative 3x, and it just gets a little confusing sometimes if we don't have an x column. That's really what we want, an x column. Okay. All right, x squared minus x squared is 0, and 0x, right? We're just thinking of it as nothing, minus 3x. That's negative 3x. And now I'm going to anticipate, I'm going to take down this negative 16. And now I think I'm on my last step. What do I multiply x by to get negative 3x? And that's just negative 3. So I'm going to write minus 3. Oops, minus 3. So minus 3 times x is negative 3x. Negative 3 times 3 is negative 9. And remember, we're going to subtract. So I'm going to do the cheat code. Change the sign. Boom. Now I'm adding. Awesome. Negative 3x plus 3x is 0. Do I have any room down here? 0. And then negative 16 plus 9 is negative 7. All right, so I have a remainder of negative 7. I can't multiply x by anything to get negative 7, not anything that's like a whole number linear term. So that's what I have left over, and so it's this simple. Here's my quotient plus my remainder over the divisor, which is x plus 3. Hey, mister, can't you write a minus there and write that as a positive 7? Sure, exact same thing. We could do that. So I could change this to a minus and get rid of this negative as well. Either way, we had two different forms we saw here. Awesome. That's the last example. Hopefully this video helped. Leave questions, suggestions, stuff like that below. Like the video, subscribe, do all that stuff to support me. But most importantly, keep flexing those brain muscles, and I'll see y'all later.